Assalamualaikum warahmatullahi wabarakatuh. This is Amril Firdaus. I would like to explain about the text from Teknik Tekstil, Mr. Hendra, which is can explain about the hybrid material. And then in this circumstance, I would like to explain about hybrid yarn structure, a promising approach for thermoplastic decomposition. So let's start the presentation. This hybrid yarn structure promising approach for thermoplastic decomposition. This is a presentation based on 2024 review by Freire and Friend, and then Journal of Composited Material, volume 58. What will be explained here in this presentation will be explained natural-based hybrid yarn, which is offering a promising solution for the future of thermoplastic composition, balancing sustainability, performance, and the most important is cost. While industrial adoption is still limited, ongoing research and technological advancements are paving the way of wider use of these ecological materials. Hybrid yarn have a strong potential to meet demanding industrial application, especially in environmental awareness and the need for greener alternative continue to grow, because this is relative of environment, green environment. So before I continue to explain about this side, let's see the video which is related with this presentation.
We, at Allied Market Research, came up with another new video on the thermoplastic composites market. It outlines what are the emerging trends in thermoplastic composites market. Let's explore. The growing demand for producing lightweight and less CO2 emitting vehicles are driving the demand for thermoplastic composites. Characteristics of thermoplastic composites include insubstantial weight, superior strength, weather-resistant finish, and various surface textures. This, in turn, is expected to increase the demand for thermoplastic composites in aerospace industry. Did you know? PolyOne Corporation, a key player in the thermoplastic composites market, launched new thermoplastic composite products at ChinaPlas 2019. It introduced complete LFT formulations, which is a thermoplastic composite with PEEK and PP as a base resin. This product is launched to meet highly demanding design and performance requirements. Companies such as Toray, T-Gene Limited, Hexcel Corporation, and SGL Group use their proprietary composite manufacturing technologies. The North America thermoplastic composites market is projected to grow at the highest CAGR of nearly 6.4% during the forecast period. Leading market players, startups, and investors can benefit from the market analysis by determining growth factors, opportunities, competitive scenario, and regional landscape to determine steps required to attain growth and stay ahead of the competition. To know more about the global thermoplastic composites market, kindly visit our website. Contact us for availing our report that contains an in-depth analysis of the current market strategies. We, at Allied, provide unmatched quality of market research reports and business intelligence solutions to global enterprises as well as small and medium-sized businesses. Subscribe, stay tuned with us for the next video.
Yeah, this is this film, which is explanation that the market of composite yarn and then also composite material is very wide and then very challenging market and then very good growth in next 2036. Yeah, I would like to mention later the growth of the market potential in this product. This time I would like to explain about what is the challenge and the opportunity about this hybrid yarn. The challenge is traditional composite is using thermoset resin and then carbon glass fiber. They are strong and light, but they're having problem about environment costs. You know, the most important is now is environment cost expensive because of waste, cannot recycle and everything, something like that. And then the second challenge is they are energized to intensive to produce and difficult to recycle on and up and in landfill. So this has become a problem also because takes so many time, so many years, or even 100 years to recycle this kind of material. So the opportunity is thermoplastic, biocomposite. Biocomposite, this mean biometric, use thermoplastic like PLA, polylactic acid. This can be melted and recycled, such as coming from cornstarch, and sugarcane. And then the second is bio-reinforcement. Use natural fiber like flax, hemp, which are renewable, low cost, and the most important is biodegradable. And then the big problem of this product is poor impregnation, does not sufficient penetrate. Why aren't thermoplastic biocomposite anywhere, everywhere? Because they are high viscosity. When thermoplastic polymer melt, they are thick and sticky like honey. Pour went out. This thick resin struggle to soak and into the fully wet and then tightly packaged natural fiber. By the result, the final part of dry spot, void, and the weak point, this lead to poor mechanical performance and failure. What is the solution? The solution is hybrid yarn. If the metric can't get to the fiber, bring the metric and the fiber together from the start. So this, I would like to explain what is a hybrid yarn. Hybrid yarn is a single yarn that intimately blend and the reinforcement fiber, such as like a flax, which is with the thermoplastic material fiber like PLA, like I explained before. How does it solve the problem? So when the hybrid yarn is heated, the metric fibers only need to melt and then flow a tiny distance, like micron, to fuse with the reinforcement fiber. So this will be give the excellent uniformity impregnation, and then fewer void, and the most important is stronger and more reliable final part. Key hybrid yarn structure. So there is several way to blend the fiber, which is with different properties, such as like coming lining, wrap spinning, core spinning, and ring spinning. So this the different from this kind of making yarn. You can see in the right side in the picture, like coming reinforcement and matrix filament are mixed together using jet or air. So combined with normally in Murata jet spinning or air jet yarn, they are just fluid together and then flew by the air by the jet system, and then will be create uniform and intimate blend. And then the second is warp spinning. The core of stable fiber, like flax, is held together in outer wrapping and then matrix filament like PLA. You can see in the second picture. See how this core stable fiber is held together with the outer wrapping of matrix filament. And then core spinning. Core spinning is more fluent with the spinning people, which is core. One yarn become a core like flax or whatever the fiber, completely seated by another fiber like braid. Then the ring spinning, another is stable fiber. Both type are twisted together traditional spinning process. So they are mixed or and blend in the following system. And then from this yarn, say from the hybrid yarn, which is we already make yarn, and then yarn structure we already explained, it will be coming from yarn to final product. So there is 3 steps to make a final product from this hybrid yarn. Number 1 is yarn production. Yarn production, this is create hybrid yarn, like I explained in the previous slide. And then the second is fabric preform production, like weave, knit, or lay the hybrid yarn into the desired 2D or 3D shape preform. And then after that, the last is number 3 is consolidation hot pressing. You can see in the right side, they put fabric perform in a mold, apply heat to the male thermoplastic fiber, they apply pressure, and then after that cool the part to get a final solid composition. You see the picture from yarn production, structure production, composite manufacturing, and then solid cross section or the final product. And then after that, fabric structure, which is made from this hybrid yarn, can be made with many different type of fabric, like woven, knitting, and then what we call it UD or unidirectional. Woven, we know already the traditional interlace structure, like plain or twill weaving. And then this make good stability and strength in the two different direction, like 0° or 90°. Knitted fabric, normally they're apply in interlock loop yarn, and then this will be get excellent drape ability, can be stretched to the form of complex curve or shape. And then the third is unidirectional or UD. All fiber are lining in a single direction. And after that, provide maximum possibility strength and stiffness in that one direction. This layer can be stacked at different angle, 0°, 90°, or 45° to build a part. Okay, then the other big problem is addition. Addition is the key. Natural fiber and plastic do not naturally stick together. The chemistry mismatch. So natural fiber cellulose are hydrophilic. they love water. While polymer matrix like PLA or PP, they are hydrophobic. They hate water. By the result, a very weak bond interface between the fiber and the matrix. This means under stress, the fiber just pull out instead of transferring the load. You know what I mean? So this addition will be strengthened together. So that's why need good addition and then good performance to mix out this both of hydrophilic and hydrophobic uh, properties. The solution, like I mentioned, need to be good approach to stick together this kind of two different material. The solution is fiber surface modification. So we must pre-treat the natural fiber to make them stick to the polymer. The goal is clean the fiber surface and make it more chemically compatible with the matrix. Common method, they are doing chemical treatment like alkaline, like NaOH, and then remove impurity wax linen and rough of the fiber surface. Silane act as a chemical bridge on handshakes that can bond the both of fiber and polymer. So this alkaline and then this silane stick together. And then the last is people are doing physical treatment like plasma or corona. Use high energy gas to etch the fiber surface and add new active chemical groups. What about the bio part? Biocomposite can mean two different things. Bio-based polymer made from renewable biological resources like corn, sugarcane, example, BOPA, BioPAT. So key point is bio-based does not always mean biodegradable. For example, BOPE is identical to regular polyethylene. And the second is biodegradable polymers, designed to be broken down completely by microorganisms. Example, PLA, PHA, PBAT. So this is easily to recycling. The key application to the automotive industry. The automotive sector is the biggest driver for this material. Why? Because they are lightweight. Lightweighting like the car, better fuel efficiency, and then longer range for kilometer, 1 liter, something like that. And then sustainability. Meet strict government regulation on emission and end of life recyclability. I'm sorry, this is I get a flu, so my voice is a little bit sexy. So where they are used, this automotive industry, they are normally used in a non-structural and semi-structural part. In rear door, panel, seat back and rest, trunk liner, parcel shelf, and then center console tray. So in the real world automatic, you can see so many brands. You can say the exclusive brand like Mercedes-Benz, BMW, Audi, Porsche, Polestar. Even in Indonesia, people in Toyota is making by this kind of product. So from hybrid yarn, they are making composite and then biodegradable and then put in a car. You can see this is the future of the market growing rapidly. Biocomposite market size people prediction until 2032. This is in billion. You can see the trend is always up. Why? Because now in Europe and in the other country, in the advanced country, they need the most important is ecological friendly, green friendly, something like that. So the prediction until 2032 will be always growing up. You can see in the graph there is massive growth from 25 billion in 2022. It will be reached 145 billion US dollar by 2032. Why? This is can be sure, and then people are seeing the massive growth. Number one is because automotive need lightweight, and construction is decking and ceiling proofing, electronic for casing, and then housing. Consumer demand for green product, it will be surrounding all the world. People are need to be green product. What next? What next will be happen? While promising, there are still area to be explored. New fiber sources. So we need most research focus on flax and hennep. We need to be explored to the other natural fiber, like pineapple, maybe like rami. Maybe we can have this kind of reset later. And then we need reset also maybe in the regenerated cellulose. This is a huge opportunity. Fiber like lyocell or rayon are naturally based from the wood pulp, but are produced as a uniform, continuous filament like carbon fiber. This best of both worlds approach bio-based plus high performance. It's a key. It's a key area to future research. So we can give direct comparison. We need a more study that directly compare the performance of composite made from different yarn structure coming out like V versus wrap spun or ring spun vs argent yarn. This is and then compare with using exactly the same material. Then for the final, I'd like to make some conclusion in this journal. Number one goal is we need sustainability, recyclable, and then lightweight material. Then thermoplastic and then biocomposite are the answer. The problem is hard to mix thick melting plastic, thermoplastic with a natural fiber reinforcement. But we have solution, hybrid yarn. Solve this by blending the metric and the reinforced fiber before melting. So the key to make this perfect is surface treatment. Excellent are critical to ensure the fiber and metal stick together. At the impact, the automotive industry is already adopting this material and the market set to expand rapidly. Okay, thank you very much for my explanation. I'm very sorry because of my voice, and then I'm also I know voice is so sexy, yeah, because I'm flu. Thank you very much again. And then if I need your correction or if any advice, we are most welcome to receive it and for further discussion. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.